All right, guys, welcome here. We are with Felix Leupold from Gnosis. He is a developer there, and welcome to the Daily Exchange.
I'm glad to be here. Thank you.
We're here at EDCON 2019, and Gnosis traditionally has been known as a prediction markets coin, and you have an exciting project to talk about as well coming up. But you know, do you want to talk to us about where's this project started? What's the genesis?
So if you think about how prediction markets are implemented on the Ethereum blockchain, it's basically the most simple prediction market you can have is a binary event. Will, let's say, a hard Brexit happen, yes or no? And what you're doing is you're putting in a deposit token, let's say DAI or ETH, and you're getting two outcome tokens, the yes, hard Brexit will happen, or no, hard Brexit will not happen token. And you sell the one that you believe will not happen. You sell this for a certain amount of money, and you keep the token that you think which outcome will happen. When the event is resolved, you'll be able to go back to the smart contract and exchange the winning token to get your deposit money back. So your winnings, basically, of a prediction market trade is whatever you sold the tokens you didn't hold on for before the event resolved. Now, with a lot of prediction markets we are hoping to see in the future, we'll have a lot of these tokens that need to be tradable, and they might be somewhat low liquidity compared to the high rolling tokens on the Ethereum network. And so we're looking to find a market mechanism to exchange these tokens that potentially have low liquidity in a very fair and decentralized way to make prediction markets fully tradable.
Okay. And why are sort of continuous order books flawed in doing this?
So today, what we see with centralized and decentralized exchanges are these kind of pseudo-continuous order books. And I say pseudo-continuous because even if they are on the blockchain today, you're kind of running in discrete block time limits, so it's not really continuous. But one of the biggest problems we see there is because we have market makers and market takers, kind of the market takers have an advantage if they see the orders earlier than other market takers. So you have this classic front-running problem where people are trying to fill very beefy orders or even accidental orders where somebody forgot a zero or added a zero too many before other people can fill them. And you see this kind of, it's an inefficiency in the market that people are trying to just race against each other in order to fill these kind of beefy trades. And this really goes to the expense of the people, of the everyday traders that are just trying to exchange their assets. So we think that a market mechanism where we can actually batch orders together over a discrete amount of time, have them sealed while they're being collected, and after a batch is closed, reveal from every participant what their limit or price was, will make a much fairer exchange where front running isn't possible.
And will that happen over a certain period of time, or how fast will that be?
Yeah, so we envision something like 3 to 5 minute block times. So you would have, you would collect orders on the Ethereum chain over the course of 3 to 5 minutes. And then once a block is finalized, people reveal, and then we would try to find a single clearing price between all these orders, so that also if you had accidentally put in an order that is very beefy, you would not be overpaying. Everyone in the batch will pay the same price.
Okay. And so maybe if you can explain, so what is your solution that you're actually building?
Right. The other thing that's important about this exchange is that in order to support low liquidity tokens, we're not going to have a batch for each token pair. There's not going to be a separate batch for, let's say, GNO ETH for Omisigo ETH. All the possible trading pairs are going to be collected in the same batch. And we're going to have an optimization solver that is trying to run over the entire amounts of orders that are in a single batch and try to fulfill them even indirectly by going over what we call ring trades. So if somebody is willing to trade ETH for GNO, but nobody is willing to do the reverse side, but maybe somebody is willing to trade GNO for OMG, and a third one is trading OMG for ETH, we can fill the trade by just going in the full circle, rather than just fulfilling direct matches, as is the case today on traditional order books.
Okay.
And so to make this scale, of course, this optimization problem is very hard computationally. This is going to run off-chain on a AWS cluster, maybe even with GPU support, so this doesn't have to run on chain. The only thing that has to run on chain is verifying that a given solution, a found solution with basically the orders that are going to be executed, is correct. And by correct means we mean all the limits have to be respected. There cannot be any tokens burned or minted in the batch. The number of tokens going in, going out has to be the same. And the last one is we are not going to have any arbitrage within a single batch. Mm-hmm. So the prices are inside a batch between all tokens are going to be arbitrage free. And these three constraints can be effectively checked inside a zero-knowledge proof, inside a snark. And so we're going to have different operators trying to compete for the best trading volume. And the one who is able to come up with the best solution will provide a snark to the blockchain that transitions the previous state, considering all the orders, into the next state where the trades are executed.
Wow. And who are these people who are competing? How does that sort of work?
Right, so it's going to be completely decentralized, so we don't know who's competing, and it's basically kind of a proof of optimization, if you wish to give it a name.
Proof of optimization, I like that, proof of optimization.
So it's an NP-hard problem that we're trying to solve, so there's going to be some heuristic involved, and so you can imagine different solvers trying to find the best trading volume and getting to different results, and there will be a smart contract where you can submit your solution, and the smart contract will pick the best, highest contribution, and that person will, or that client will provide the full solution on chain and the snark that does the state transition and will be rewarded with the fees that people pay for submitting orders on the exchange.
Okay, and it is, you said it's an NPR problem, so it's a bit like, what that means, I guess, is it's I guess a knapsack problem to some extent. Like there's no actual. Yeah,
it's technically a linear optimization problem that I'm not working on the actual solver, so it has a class that is usually NP-hard. Okay. And so for the solution that we have at the moment, that is kind of as hard as the knapsack problem. Yeah. It's infeasible to find the best solution for, let's say, 1,000 orders.
But they're all competing, I guess, to figure this out, and hopefully then that makes a really efficient matching engine, right?
Right. And so if somebody even had a monopoly and saying, like, I have the best algorithm, they would be able to they would be able to get the fees, but at the same time, they would only provide solutions that are good for the entire network and that create a high trading volume. So it's really good for everyone in the network.
So do you expect that to be, you were talking about ZK snarks, and is that something, I guess in terms of scaling that and imagine when there's, I can imagine when this optimization problem is very, very big, how do you expect that to sort of work, I guess, to scale it?
So the snark is basically limited by the amount of orders that we can verify in one single proof. And kind of snark is the technology that we're looking at the moment, but we might be using Starks in the future, or any kind of zero-knowledge proof system that can be succinct and compress. And yeah, basically all the zero-knowledge proof has to do is take the list of volumes that are executed, take the list of orders that have gone in, and check that the price of this order has been respected, as in the limit price has been met. And then just subtract the amount of sell tokens from the existing balance, add the amount of buy tokens to the existing balance, and that will give us the updated balances in the exchange. Hash everything together and commit that on the main chain.
On the main chain.
So, okay, right. So it's really the amount of orders that we can process in a single batch that's kind of the limiting factor. At the moment, we are sure to do 1,000 orders per batch, but we are hoping that with compression, we can get this up to 10,000 or even 60,000 orders per batch.
Wow. Okay, incredible. Now, in terms of timeline, when is this sort of all happening?
Right. So we're working on getting a prototype out at the moment, and hopefully we'll be able to show something like a very basic prototype to kind of demo and showcase the exchange mechanism, kind of this discrete batch auctions with uniform clearing prices and having all token pairs in the same batch by the end of the half. And then we're going to continue working the Starks in, or the snarks in, and kind of making this really fully decentralized. And yeah, we'll launch as soon as we are ready. But yeah, we're hoping to get something in the next 6 to 9 months.
Okay. And in terms of with Gnosis, I guess, What are you really excited about, coming up?
I'm really excited about zero-knowledge proofs and the entire the ecosystem as a whole, how fast things are moving. Like the fact that we don't even know yet which zero-knowledge proof system we're going to employ for something that we're willing to launch 6-9 months down the road kind of shows how fast the space is moving and how many new technologies are arising. And that is something that is extremely exciting, I think. And the beauty behind zero-knowledge proofs is very very humbling and very, very mind-blowing. I think it's an interest, very, very cool technology.
And today in some of the other talks, anything that sort of caught your interest?
I thought that the explanations on how the proof-of-stake algorithms are working were very interesting and were presented in a very understandable way. So I thought that was actually the first time that I heard them being presented in a way that they're really easy to understand and follow, and people can now watch and understand how CBC Casper, for example, will work.
Yep, brilliant. All right, anything else that you're seeing as sort of major challenges right now with Ethereum and things that you're interested? I don't know if you've looked at the PROG POW.
I have not looked at that, but one thing that I feel somewhat passionate about is the state rent proposal. So the problem with Ethereum at the moment is that our full nodes are growing and growing in size, and it's becoming increasingly harder to store an archive node on a single machine, or even store a full node on a laptop or something that can be decentralized in the way that people like you and me can actually host it. Yes. And so having an incentive mechanism that makes sure you're cleaning up after yourself if data that has been stored is no longer needed, or at least making you monetarily reliable for keeping data on chain is a proposal that makes a lot of sense, and I think it's important to keep the system decentralized.
Brilliant. Felix, if anyone wants to sort of get in touch with you, what's sort of the best way if they want to come and contribute and help? What's the best way to do that?
Yeah, we have all of our repos open source on GitHub, so that's github.com/Gnosis, and then the projects for this exchange all start with DEX, kind of the repos that's starting with DEX.
Okay.
Comment there, create an issue, create a pull request. My email is felix@gnosis.pm. You can reach out directly. We're here at the conference, happy to talk to anyone, so very open for collaboration.
Brilliant. Thank you so much for joining us on the Daily Exchange, Felix.
Thank you very much for having me.
Okay.
Pleasure.
Thanks very much, guys. That's Felix from Gnosis. Do subscribe and do follow us. We'll see you guys later.